and leveling effect in this video. So many a times students find it difficult to understand how the solvent dictates the acid strength of an acid or acidity of an acid. For example, if you use some acid in water, its acidic strength would be different as compared to if you use in some other solvent. Let's try to understand this with an example. So when you dissolve an acid, say your acid is HX, you dissolve this in a solvent, then the solvent can take up this proton from the acid, okay, and what you get is you get a protonated solvent and the conjugate base of acid. Okay, now it depends upon, like, if you want to know the acid strength of HX, it would be determined from the equilibrium constant for this reaction, okay, of the dissociation of HX. Equilibrium constant, like if the equilibrium constant is bigger, which means that the forward reaction is favored, which means that the solvent's basic strength is quite high, it will abstract the proton and convert the acid to its conjugate base. Fine. So it means that the basicity of the solvent, basic strength of the solvent affects the acid strength of the acid. So an acid can behave as an acid in a solvent if the solvent is ready to take its proton. We are talking about the interaction between the solvent and the acid. Okay, now let's try to understand this with an example. Now suppose you dissolve hydrochloric acid, nitric acid, and perchloric acid in water. Okay, you dissolve them in water. So what is observed experimentally, that when you dissolve all these acids in water, so HCl plus water, so water takes up the proton, okay, and what you get is hydronium ion plus chloride ion. In such a reaction, the equilibrium is mostly towards the product, like 100%, almost 100% towards the product side. That is, hydrochloric acid is totally dissociated. So is the case when you dissolve nitric acid in water. Again, the reaction is more towards the product side, like almost 100% towards the product side. Okay, so is the case with perchloric acid, 100% dissociated. It means that in water, all the three, they stand at the same level in terms of their acid strength. So water has leveled them at the same place as a solvent. Water has leveled them at the same place in terms of their acidic strength. It means that in water, the acid strength of HCl is equals to the acid strength of nitric acid is equals to the acid strength of perchloric acid. You cannot differentiate between their acidic strength because water is acting as a strong base here. So water is a solvent, but it is acting as a base here. Now if you dissolve the same three acids, hydrochloric acid, nitric acid, and perchloric acid, in acetic acid, acetic acid is a weak acid in comparison to all these three, so it will act as a base. So if you dissolve hydrochloric acid in acetic acid, so what happens is that this gets protonated, it acts as a base. Acetic acid acts as a base here. Okay, so same is the case with nitric acid and perchloric acid. So when we observe the K equilibrium or their acid strength in terms of the equilibrium constant or the dissociation of acid in acetic acid, what we observed is that the acid strength of perchloric acid is more than nitric acid, which in turn is more than hydrochloric acid. This is when they are dissolved in acetic acid, which is a weak base in comparison to water. It means all of the three which were leveled, which were at the same level in water, water had brought them to the same level in terms of their acidic strength. They were not actually having the same acid strength. Their relative acid strength in acetic acid is this. So although they are not inherently, they were not equal, their acid strength were not equal, but water brought them to the same level. So this is called leveling effect. It has several applications in organic chemistry that we'll see in the next video. Thank you.